Good morning, children. Today we are going to see a new topic, and the name of that topic is arithmetic progression. So this is a new chapter, chapter number 3. The name is arithmetic progression. In this chapter, we are going to study the new terms which are used in this. The first is sequence. What do you mean by a sequence? Now, sequence means when the numbers are arranged in a definite order. So that is called as a sequence. For example, see, you know natural numbers 1, 2, 3, 4, 5, 6, 7, 8. So they are arranged in a definite order. So all the set of numbers, real numbers, natural numbers, whole numbers, all these will form a sequence. So sequence is nothing but when the numbers are arranged in a definite order. Now here in this sequence, the terms are divided by T1, T2, T3, T4, Tn and so on. For example, I told you natural numbers. Natural numbers, see, 1, 2, 3, 4, 5 and so on. So here, this is my first term, this is my second term, this is my third term and so on. So there will be an n term here which I will by the letter Tn. So n term and then so on. So T1, T2, T3, T4 and so on. Tn will represent the terms of that sequence. Next, we are going to see a sequence that is known as arithmetic sequence. Arithmetic sequence or arithmetic progression. Now, what do you mean by this arithmetic progression? Now, for example, see 2, 4, 6, 8 and so on. You find after 2 there is 4, after 4 there is 6, after 6 there is 8 and so on. So you find that there is some relation between these two terms. 2 is the first term, T2 is the second term, T3 is the third term and so on. So here, if you observe between the two consecutive terms, any two consecutive terms you take, for example 4 and 2, you find that the difference is 2 here. The difference is 2 here. If you take 6 and 4 as the consecutive terms, 6 and 4 difference is again 2. 8 and 6 difference is again and so on. So what is happening here is, you find if you choose any two consecutive terms and if you find the difference of these two consecutive terms and that if it is constant, then you say that the given sequence is a arithmetic progression. So how are we going to check whether the given sequence is a arithmetic progression? So for that, you have to take any two consecutive terms, and if you find that the difference in these two consecutive terms is constant for any two consecutive terms, if the difference is constant, then you say that the given sequence is a arithmetic sequence. So in general, suppose this is my T1. See, my T1 is what here? 2. My T2 is what? 4. My T3 is 6. My T4 is 8. What we have to check minus T1. Difference in the consecutive term. So T2 minus T1. How much you get here? 4 minus 2, which is 2. You take T3 minus T2, which is 6 minus 4, which is 2. You take T4 minus T3, which is 8 minus 6, which is 2. So you find that the difference in any two consecutive term remains constant. 2, 2, 2. So that is constant. And so if you get such a thing in a sequence, then you say that the given sequence is a arithmetic progression. We take one more example. I will take say 3, 5, 7, 9, 11 and so on. What is my T1 here? My T1 is 3. My T2 is 5. My T3 is 7. My T4 is 9. Again you find the difference. T2 minus T1. 5 minus 3, which is 2. T3 minus T2, which is 5. 7 minus 5, which is 2. T4 minus T3, which is 9 minus 7, again. So you find that the difference in any two consecutive terms remains constant. 2, 2, 2. So if you get such a difference which is a constant, that means the given sequence is a arithmetic progression. Right? Now, in general, this is T1, T2, T3, T4. So what I am doing is, I am taking T2 minus T1, T3 minus T2. So like that, there will be a term Tn minus 1, Tn, Tn plus 1. These are the terms in the sequence. So in general, if you find Tn plus 1 minus Tn, if this is constant, the difference between Tn plus 1 minus Tn, the difference if it is constant for all n, means n you take any value, 1, 2, 3, 4, 5, 6. So if you find that the difference Tn plus 1 minus Tn remains constant for all n, that means the given sequence is a arithmetic sequence. Is that clear? And if you find that the difference is not constant, then the given sequence is not the arithmetic sequence. So in short, what you have to remember, whenever it is asked, check whether the given sequence is an arithmetic progression, you have to find the difference in the consecutive terms. Right? So don't find only for one, find for more than 2. Like what I did here. See, T2 minus T1, T3 minus T2, T4 minus T1. 3. So for at least 3, you show that the difference is constant. Then you draw your conclusion that the given sequence is a arithmetic sequence. Right? Now, here, for example, take one example, say 3, 5, 7, 9, 11 and so on. Now here, the first term I am given by the letter A. My A is the first term of the sequence. Then T2 is here 3, T2 is 5, T3 is 7, T4 is 9, T5 is 11. The difference which is there between two consecutive terms, so that difference I will denote by the letter D. So D is the common difference. D is the common difference. Means, look here. and same way T3 is equals to 9 minus 7, which is 2. So in this case, this difference is denoted by the letter D. So D is the common difference. So remember, A is the first term of the sequence and D is the common difference. Right? Now, I hope you have understood what is arithmetic progression. Brief revision of that. Whenever you want to check whether a given sequence is an arithmetic progression, you have to take any two consecutive terms, find the difference, and if the difference is same for all, then you say that the given sequence is an arithmetic progression. If it is not constant, then you say it is not a arithmetic progression. What is my A here? My A is the first term of the sequence. And what is my D? D is the common difference. How do we get that common difference D? By subtracting any two consecutive terms. Right? Now we'll see some examples. See, open to page number 61, practice set 3.1. So which of the following sequence are AP? If they are AP, find the common difference. Now 2, 4, 6, 8, that is the first sum which I already done. Now check for the second one. The second is 2, 5 by 2, 3, 7 by 3, and so on. This is the second sum of exercise 3.1. Now you are asked, this is for 1 mark answer, remember. Your sequence is 2, 5 by 2, 3, 7 by 3, and so on. You are asked to check whether this is a arithmetic progression. So what you will do here, first of all you see what are the terms given here. This is my T1, this is my T2, this is my T3, this is my T4. Okay? So I'll write down first what is my T1. So T1 here is here. T1 is 2, T2 is 5 upon 2, T3 is 3, and T4 is 7 upon 2. Correct? Now what you do? You say consider T2 minus T1. What is T2? 5 upon 2 minus 2. Now this you have to simplify. So 5 into 1 is 5 minus 4. So 5 minus 4 upon 2, which is 1 upon 2. So T2 minus T1 is 1 by 2. Check. T3 minus T2. What is my T3? 3. Minus. What is my T2? 5 upon 2. So LCM. LCM is 2. So 2 into 3 is 6 minus 5 upon 2, which is 1 by 2. Then you check T4 minus T3. What is my T4? 7 by 3 minus 3. So T4 minus T3 is 7 by 3. What is my T3? 3. So 7 by 3 minus 3. What is LCM? 3. So 7 into 1 is 7 minus 9, which is equals to minus 2 by 3. Now look here. T2 minus T1 is 1 by 2. T3 minus T2 is also 1 by 2. But your T4 minus T3 is not 1 by 2. It is minus 2 by 3. Even though these two remains constant, the third is not the same. So here the difference between the two consecutive terms is not same. It is not constant. And therefore, this given sequence will not form an arithmetic sequence. So how to write? So you have to say here, which is not equals to half. Minus 2 by 3, which is not equals to half. Therefore, Tn plus 1 minus Tn is not constant. Is not constant. You understood why I wrote not constant? Even though first two difference is same, but the third is not same. So since this is different, therefore Tn plus 1 minus Tn is not constant. Or you can write in words that the difference in the two consecutive term is not constant. That also you can write. If you don't want to use this symbolic expression, you can write in words that difference as the difference in the two consecutive term is not constant. You can write that as the difference in the two consecutive term is not constant. Is not constant. Therefore, the given sequence is not an AP. Now, AP means arithmetic progression. I hope you understood this. You can write this or this. This is one and the same, right? So it's up to you whether you want to use the symbolic expression or you want to write in word. So this is not an AP. I hope you understood this. Correct? Okay. We'll take one more example of this. I will take the sixth one. 1 by 5 minus 1 by 5. Minus 1 by 5, minus 1 by 5, minus 1 by 5. Now, so you find that each term is same here. Minus 1 by 5, minus 1 by 5, minus 1 by 5. So here what is my T1? My T1 is minus 1 by 5. What is my T2? Minus 1 by 5. What is my T3? Minus 1 by 5. So you find that T2 minus T1, T2 minus T1 is minus 1 by 5, minus of minus 1 by 5, which is minus 1 by 5 plus 1 by 5, which is 0. T3 minus T2. What do you get here? Minus 1 by 5 minus of minus 1 by 5 is equals to 1 by 5 plus 1 by 5, which is 0. Now again T4 minus T3 minus 1 by 5 minus of minus 1 by 5 is equals to minus 1 by 5 plus 1 by 5, which is equals to 0. Now you must be thinking that, sir, only 3 terms are there, T1, T2, T3. Where is the T4? See what is happening here. Minus 1 by 5, minus 1 by 5, minus 1 by 5. So all the terms of this sequence are minus 1 by 5. So this you can write as minus 1 by 5 and so on. So it is same. So your T4, T5, T6 up to Tn and ahead of that will be having the terms minus 1 by 5. So you find that the difference as the common difference is constant. See, I did for 3, 1, 2, 3. For all the 3, the difference is 0, which is constant, and therefore given sequence is an AP. So the given sequence is an AP. Now they asked you to find the common difference. So given sequence is an AP with first term A is equals to minus 1 by 5 and common difference D is equals to 0. Is that clear? So first term is my A and D is the common difference which is 0. Is that clear? Now question number 2 is given to you. It says that you have to form a sequence where you are given the first term and the common difference. A is 10, D is 5. Now all of you know what is A and what is D. A is the first term of the sequence and D is the common difference. You are asked to form a sequence. It's an A. It's given. Now how to form the sequence? So obviously A means your first term. Correct? So my T1 is A, which is 10. So I got the first term 10. Now how will you get T2? T2 will be T1 plus A. What is my common difference? My common difference is 5. So how to get the next term? See, if you know the first term and if you know the common difference, then how to get the second term? Add the common difference in the first term. So T2 will be T1 plus A. Correct? I hope this is clear. See, you want to get the next term. So since the common difference is 5, so to get the next term, add 5 to the preceding term. So T1 plus A. So that is equals to, what is my T1? 10. What is my A? Sorry, it must be D. T1 plus D. So T1 plus D. What is my D? My D is 5. So that is equals to 50. So how I got T2? By adding common difference in the first term. Correct? So remember that whenever you want to get the next term, you have to add the common difference in the term. Now to get T3. So to get T3, what you will do? You will add 5 in the preceding term. So what is the preceding term of T3? T2. So in T2 you add 5. So that is 15 plus 5, which is 20. I hope this is clear. Now you want to get T4. To get T4, I have to add 5 in T3. So T3 plus 5, that is 20 plus 5, which is 25. So in short, what you have to remember is your first term will be given to you. A means your first term, right? Now to get the second term, just go on adding 5 to the preceding terms. Now preceding term means T2 come preceding term T1, T3 come preceding term T2. So like this you go on adding 5 to the preceding terms to get the succeeding terms. I hope this is clear to you. So you get here T1, T2, T3, T4. So enough up to 4. So your given sequence is therefore required arithmetic progression is 10, 15, 20, 25 and so on. So this is your required sequence. Is that clear? We'll do one more. We'll do the third one. A is -7 and B here be careful because minus is involved and fraction is involved, right? Now what is my T1? My T1 is the first term, which is A, and that is minus 7. Correct? Now I told you how to get T2. To get T2, you have to add common difference. That is equal to minus 7 plus half. And minus 7 plus half, you know, 2 7s are 14 plus 1 upon 2, which is minus 13 upon 2. So this have to be careful. LCM is 2 here, cross multiply, you get the answer. To get T3, what you will do? Add common difference to T2, preceding term. What is my T2? Minus 13 by 2 plus D is what? Half. So LCM is 2 here. Minus 13 plus 1. That is minus 12 upon 2, which is minus 6. Correct? So you got T1, T2, T3. So your required sequence is minus 7, minus 13 by 2, minus 6, and so on. So this completes your sum. These are 1 mark. I hope you understood this. Correct? So today we are studying what is a sequence. Sequence is nothing but the arrangement of the numbers in a definite order. After that, we have seen what is a arithmetic sequence. So arithmetic sequence or arithmetic progression. To check whether it is an arithmetic progression, you see the difference in the two consecutive terms, and if that is constant, you say it is a arithmetic progression. And then we have seen some examples. In the next lecture, in the next class, I will solve more sums on this, and also we will see the end term of the arithmetic progression. Thank you.